Let's take a look. Let's analyze what you've done. Here we go. So, in this question, the first instruction says, find the critical numbers of f. So let's review. Critical numbers of f are where what happens? F prime is 0 or does not exist. So if we're going to find out where f prime is 0 or where f prime doesn't exist, we probably should have f prime. Do we have f prime? No. We don't. Remember in the last one we did yesterday, we actually did have f prime, didn't we? You had a graph of f prime, so you want to be really careful that you notice what you have and what you need. Here we need f prime, we don't have it, so we need to do a little bit of work to find it. We use the power rule once. We get f prime is equal to 2/3 x to the negative 1/3, and that is our f prime. Okay, so the first thing we always want to ask ourselves, I always do this real quick mentally, and sometimes it's no big deal, sometimes it is a big deal. Is there any value of x that would cause that f prime right there to not exist? 0, right? Did you notice that x to the negative 1/3 is really a denominator? It's really over x to the 1/3. And so x equals 0 would most certainly cause f prime to not exist. So there's our first critical number, our first possible relative min, max, or possibly neither, but it's our first candidate. Next thing we want to consider is, where is f prime equal to 0? So I'll set that equal to 0 right there. What might be a good first step in trying to solve for x here?
Divide by 2.
Let's get rid of the 2/3 by division. So I would get x to the negative 1/3 is equal to 0. Say again? Multiply, okay, so take each side to the negative 3rd power. Okay, I can go with that. So check this out. If I go negative 3rd power, you'd multiply your exponents, and negative 1/3 times negative 3 is 1, right? That's the goal. So you got to do the same thing to the other side. And what's the value of the other side? What does a negative exponent mean? It means that whatever the base is, it's actually in the denominator, right? So think about what we just did. Didn't we just really say 0, you go to the denominator? So we just forced this to be non-existent. So let's not take that. Do you see what I'm saying? You said 0 to the negative 3. That means take 0 and flip it down, and 0 cubed is 0, and something over 0, 1 over 0 perhaps. It's a major issue, isn't it? Let's go back. Let's go back to this step right here. Let's think of a different strategy. What could we do besides, that's not a bad idea. What else could we do, Johnny?
Multiply both sides by 3rd root of x.
Well, wait, say it again?
So you have 1 over the 3x, like root 3x.
1 over...
But there's no other answer that you could.
So it sounds like...
I confused myself.
So it sounds like you're saying that. 1 over a cubed root of x. Well, that's fine to do, right? You can flip it down, that's really what the negative 1/3 power means, right? Over the cubed root of x. But Johnny, I think maybe this can illustrate your point, though. I think you had the right idea. Look at that fraction on the left. The numerator is just a 1, right? It's not anything other than a 1. The denominator is a variable, right? So listen please, what is the only part of a fraction that can make the whole fraction have a value of 0? The numerator, and the numerator is, there's no way that this fraction can even equal 0, can it? And so all this work we've just done, well, not a waste of time, it's not going to yield anything. So in other words, the only critical number, the only candidate we're going to get here came from f prime not existing. So this is a really important thing for us to consider, because sometimes it's really easy just to automatically go f prime equals 0, and a lot of times that gives us lots of results, and maybe all the results, right? Often that's the case. In this case, if you didn't consider f prime DNA, you'd get no candidates, and you might think, oh, there's no mins, or there's no maxes, or no critical numbers for me to even think about. I'm done. You have to consider DNE. Don't force it, but consider it. Consider that might be a possibility, and in this case, it's the only one. Does that make sense? Okay. A little bit of algebra, wake-up call here this morning. It seems like that went okay for you. I do have that one critical number. It is 0. I'm going to show you an f prime sign chart. Josiah asked a good question. He said, do we have to show a sign chart, or is there an alternative to a sign chart? And there absolutely is. An alternative would be just don't do it at all. I don't really care. Or he said, could I use a table or some other kind of an organizing element? Totally fine. I really don't care. But what I do care about is once we kind of get ourselves figured out and we're like, okay, we see the sign change pattern, whatever, you have to write a concluding sentence that explains what you've done and what the conclusion is. That makes sense? I'll show you that example here in a second. But we do need to test out some values. So if I tried maybe -1, f prime of -1, let's see here, -1 to the -1/3 is -1 times 2/3 is -2/3. I agree. So I'll go negative right there. And then by the same kind of logic, f prime of 1 would be pretty smart. And that should be positive 2/3. Say again? Could you say that a little bit louder?
When I plug it in, you get -3. Maybe I did it wrong, but
So I'm plugging in right here. Oh, you plugged it back into F. If you got -3, you plugged it back into F. Good identification there. Okay, does that make sense? What Josiah just unwittingly did is he illustrated a really good point. Make sure that you are really testing the first derivative. Isn't it easy to accidentally test F instead of F prime? Really easy to do because in the past we have plugged numbers into F, right? Understandably, like that made sense then. We're doing a first derivative test. You want to test the first derivative. Okay, so you see the sign change pattern. Let me show you my example of what a good concluding sentence would be. I'm hoping that you worked on your own. We'd say something like this. F of x, there we go, has a local, or you could say relative min at x equals 0 because we could go f prime of 0 does not exist and f prime changes from negative to positive at x equals 0. So we're using the first derivative test where we're looking for a sign change in f prime, and that would be an example of one way you could write a conclusion. Yes, sir?
Do you have to mention that f prime of 0 doesn't exist?
So I think that that's a little redundant from what I've put up there. I kind of like to put it in there just to make sure that I don't forget that. If you, for some reason, if you didn't show this work over here, then you really have to do that. But you really need some evidence to back that up too. Where you're going to run into problems is the problem like number 3, like we did the other day, where to figure out that you got critical numbers, all you really have to do is look at a graph.
Mm-hmm.
And so since you didn't really show any work to arrive at those conclusions, you want to make sure you said that. In this case, I think it's a tad redundant.
Okay.
So I don't think you have to do it in this particular case. Yeah.
Is relative and local exchangeable?
Yeah, relative or local. I'll take one or the other. They mean the same thing. Yep. Question?
how would you write a concluding sentence if there was an inflection?
Okay, so let's say instead of minus plus, we got like minus minus or plus plus or something. So we would say f of x has an inflection point. Or here's how it depends on how the question's worded. Like if the question was worded, find critical numbers and decide if it's each critical number is at a relative min, max, or neither. Right. So if it said that, then if you got minus minus or plus plus, you'd say f of x has neither a local min nor max at 0 because, well, f prime of 0 didn't exist, f prime didn't change signs. Or if it said, find all the critical numbers and decide if each critical number is at a relative min, max, or inflection point, then you would say f of x has an inflection point at x equals 0 because f prime of 0 doesn't exist or equals 0, whatever it happens to be, and f prime doesn't change signs at x equals 0. And you'd have your numbers or your sign chart or your table or whatever evidence to back that up. You just conclude with that sentence. Yeah. Okay. Good questions. Anybody else? What if questions are almost always great, right? What if it was this? What if it was that? Why is this? Those are all really, really good. Okay. You solid? So do this for me really quick. I want you to look at what you did, and you might have made some notes and some additions or whatever as we were talking in the last few minutes. Look what you did in the first 5 or 6 minutes of class, and look at what's up there. And I just want you to make a quick judgment right now. Where am I at? Did I do that question and pretty much do it right? Like by all indications, I would have got a perfect score on that question, or would I have gotten like 0 out of 4 or whatever it was worth, or would have been maybe, did I get the critical numbers but mess up the first derivative test? Really assess yourself right now. please be honest with yourself and say, yep, this is going fantastic, I got it, or not, okay? And with that in mind, we'll kind of move forward. Still happy to take questions from you, but be honest with yourself. Where am I really at, and what do I need to do? So having looked at it like that, do you have anything you'd like to follow up with before we move on? Okay. We didn't do this yesterday, did we? Fist to 5? We did? Can you give me a fist to 5 on this one? Where are we at? On just this particular question. Okay. So, obviously if you're holding up 4s and 5s, you're saying, yeah, I'm feeling pretty strong. If you're holding up like 1s and 2s or fists, then you're like, oh, I'm a work in progress. Those of you that are holding up like those lower confusing like baseball signal like numbers, 2, 3, 1, 2 over here, whatever. Do you have anything you want to say? Do you have any questions you want to ask, or do we just need more practice? More practice. Okay, fair enough. Well, let's go ahead and move on then. Let's take a look here at our next example, which is not number 3. We already did that one. We're going with number 4. So I'm trying to give you guys lots of different angles where we can approach these. So I want to give you a broad perspective. The very first one we did, I just gave you a regular old function. You set f prime equal to 0. You found your candidates and you used the first derivative test. Number 3, the one we did yesterday, you had a graph of g prime and you had to work with that. The one we just did was back to an equation, but it was a little bit of a curveball because of the whole DNE thing. Now, number 4, same kind of question. Where is there a relative min, relative max, or neither, or what's going on there at 2? But I'm giving you this table of values. I'm trying to show you there's lots of different ways these could be presented. Please don't feel like there's only one way to do this. So, with all that in mind, you have all the skills you need to do this one, especially if you just said, hey, I'm like a 4 or 5 with this concept. You got all the skills you need. Recalling something, now I didn't say you're guaranteed success. I'm just saying you have all the skills you need to possibly be successful. So I want to give you 5 minutes again, give or take. I want you to try number 4. Feel free to work with your table partner, whatever. I'll be around to help, and we'll sum it up here in a few minutes. Okay, hey guys, please hear the logic in this. We're asked about what's happening at x equals 2. Do we have a relative min, max, or neither at x equals 2? So for this to even be a possibility, doesn't x equals 2 have to be a critical number for h? So we need to confirm that. The way that we confirm that would be to see if h prime of 2 really is 0 or perhaps DNE. So I'm going to write this. H prime of x would equal f prime of g of x times g prime of x using the chain rule because it is a composite function. But in order to confirm that x equals 2 really is a critical number, I need to take it a step further and find h prime of 2. And I'm hoping that it's either DNE or 0 because that'll allow me to continue on. So if I plug in a 2, what that means is to plug a 2 in wherever you see an x. It's tempting to get a little discouraged seeing all the stuff there. I mean, there's lots of f's and g's and f primes and g primes and x's and now 2's. But if we start breaking this down little by little, I think we'll be okay. I'm supposed to find f prime of I don't know yet, right? Because I don't know what g of 2 is. But if I look at the table, I can see that g of 2 is 3. So that means h prime of 2 is equal to f prime of 3 times g prime of 2 is negative 2. So I didn't know what it was. I didn't know f prime of what before, but now I know that it's f prime of 3. So I look at the table to find f prime of 3, and it's 0. And of course, 0 times negative 2 is 0. And so what that means then is I've confirmed that x equals 2 really is a critical number, so I can analyze it. I can look and say, hey, does the sign of h prime go from negative to positive or positive to negative or not change at all, and make a judgment from there. Does that make sense? So that's what I'm going to try. Of course, in the table, I've conveniently given you some values that are around 2. So the first thing I would do is I would look for h prime of 1. H prime of 1 would equal f prime of g of 1 times g prime of 1. So let's see here. G of 1 is 2. So it would be f prime of 2 times g prime of 1 is also 2. And f prime of 2 is 4. So I'm getting 8. And 8 is an important number to have, but what's the most important thing about 8? It's positive. So What if we just eliminated from the possibilities? There's no way that x equals 2 could be at a place where h is a minimum, right? Because for a minimum, doesn't h prime have to go from negative to positive? And h prime is positive, so we can either go positive to positive or positive to negative. You see how we've eliminated min from the possibilities? Okay. Last thing we're going to do is find h prime of 3. So h prime of 3 is equal to f prime of g of 3 times g prime, I'm running out of room, of 3. I ran off the edge there, I'm sorry. So h prime of 3 then equals, let's see here, g of 3 is 1. So that would be f prime of 1 times g prime of 3 is 2. And f prime of 1 is negative 2. So I'm getting h prime of 3 equals, did you get that too? Negative 4? Okay, so that of course is negative. And now what I can do is I can draw my conclusion. I've got a max, don't I? So I've already proven that h prime of 2 is 0, so I don't know that I need to rewrite that. I could, but I'm going to say something like this. H has a relative max at x equals 2 because h prime of 2 is 0, but h prime changes from positive to negative at x equals 2. Okay. That go okay for you? There's a lot of confusing letters and symbols in there. So I walked around and listened and talked to a few folks. I feel like you got it figured out pretty well. Do you have any follow-up questions? I'm really encouraged. I feel like you guys are handling this well. Am I reading you right? Can't say that or am I wrong? Okay. I can't say that I'm surprised. I'm just happy. It's good. I feel like you guys are all smart people and can figure stuff out. That's good. Hey, one little note here. I don't know if they would ever do this again. I know last year on the AP test, on the operational exam, on one of the free response questions, they have all these like silly, nerdy nicknames for the questions. This one question on the FRQs, they called it alphabet soup because there was like 6 different functions. You can actually look this up if you want, F, G, H, J, K, something or other. There's like 5 or 6 different functions. You had to do all kinds of crazy stuff with them. And the fact that you guys were able to, it's seemingly at least easily navigating the H, F, and G. I feel like you guys kept those straight. That's very encouraging because I know for a lot of students last year, all those different functions line up. I mean, they tried their best to keep them all straight, but there's a lot of folks that kind of mixed them all up. So keep working at it. Make sure you're naming them H, H prime, F, F prime, G, G prime. They're all different. They all have different meanings, and we just kind of have to sort through all that. So nice work. Let's take a look here. I think we got a little bit of an application. Yes, we have an application. This is going to go good. We're going to get this finished up, I think. Take a look at example number 5. Calculator is active. Let's read it together. It says, a local car dealership is receiving new cars from the manufacturer at a rate of R of T. So they're coming in on trucks. The dealership is selling cars at a rate of S of T. At what time on the interval? Oh, sorry, that should just say on what time on the open interval. Sorry about that little typo there. On what time on the open interval 0 to 10 is the number of cars at the dealership at a relative minimum. So we're going to come back around and revisit these applications when we get into I think 3.7, something like that. I thought we'd do one here today. So, anybody tell me what we've got here? Have you looked through some of the key wordings here? You've got R of T, you've got S of T. Those are obviously very important. Can anybody tell me some important stuff about R of T or S of T? They're both rates. Did you catch that? The word rate is right in there. The units indicate that as well. So you got 2 rates here. So I'm going to underline those, kind of like what we've done with related rates in the past. I'm going to underline those important rates. I'm looking for a relative minimum. You can see that. Looking for a relative minimum, but I got these 2 rates. So there's a couple of ways we can deal with this. But let's think a little bit ahead. If I am trying to find where the number of cars is at a minimum, my only candidate would be a critical number, wouldn't it? minimums, maximums. I got to be looking for critical numbers. Okay, so if I'm looking for where the number of cars, or when the number of cars is at a minimum, to find a critical number, what do I need to do? Set the derivative equal to 0 and possibly dne, right? Okay, so then if you stop and think about this, you say, okay, I need to set the derivative equal to 0 or dne. The derivative of what?
You don't need to do any derivatives since we already have rates.
Yeah, we don't need to do any derivatives because we already have rates. And so, this is where it'd be confusing, and you might be tempted to find r prime or s prime.
It's like the code thingy.
Say again?
It's the tank.
It's the water tank. I was waiting for someone to recognize that. It's the water tank. So instead of water flowing in and water leaking out, it's cars flowing in and cars leaking out, right? So it's the water tank question all over again. So you can do this a number of ways. Here would be one of the easier ways. You could say the rate coming in is r of t, so that would be positive, and the rate leaving is s of t. So we're going to subtract that. So r of t minus s of t, that is what we call the net rate of cars at the dealership, right? It's the net rate of change of cars at this dealership. So if we really are looking for a critical number, what should I do with that net rate? Consider what first? Doesn't exist, right? Consider dne. So seeing what r of t and s of t are up there, are there any t values that would cause r of t minus s of t to not exist? 0? But 0 is not even part of our interval. It's not part of our domain, right? So while 0 would cause that, r of t minus s of t to not exist, we don't consider it because it's not in the domain. Anything else? Any other t values that would... negatives would, right? Because if you starting with -1 essentially, if you went -1 or less, then wouldn't that make it ln of 0 or ln of a negative? You can't do that either, and you can't even consider that because domain. Yeah, our interval is from 0 to 1, open on both. So you want to at least think about that, but I think you can successfully navigate that. You don't want to just ignore it. You don't want to stick your head in the sand and say, oh, that'll never happen. You have to at least consider it, and you can dismiss those based on some good reasoning there. So after all that, I'm simply going to say r of t minus s of t is 0. You look at those two functions there. A little messy. Not too bad. What's the saving grace on this question? Calculator. Yes. So what you got to do is use your calculator, find out where r of t minus s of t equals 0 by, probably using the zero finder, or you could just find the intersection point between the two of them. It's the same thing. Bottom line is we need to solve this to get a critical number. Okay, so guys, 2.817 is a critical number. In fact, isn't it the only critical number on this interval? Okay, so if you were just to stop right here and say, 2.817, you really haven't finished it yet, right? All you found is a critical number. What you need to do here, what you can do, is you can take the information right off of your graph that's on your calculator, and you can use it. So take a look at your calculator screen. To the left of 2.817, what's the value of r of t minus s of t? It's negative, and to the right it's positive, and so you can go directly from your calculator screen to a concluding sentence and say something like this. R of t minus s of t. We already know that it equals 0 at that 2.817. We've already proven that, but we would say r of t minus s of t changes from negative to positive at t equals 2.817. Therefore, the number of cars is at a relative min at t equals 2.817, and it is hours, I guess. We could put that in there. Okay. Are you getting the hang of that concluding sentence where you tie it all together? Is it making sense? Is it days? Oh, it is days. Somebody said hours earlier, and I just followed right along. Yes, it is. It is days. I should have read the question. That would have made it better. Okay. Follow-ups, questions, thoughts, comments, anything? Yes, ma'am.
What does that say? Number of cars is at
A relative min. So that's, I apologize for my messy writing. This is not the most precise stylus. Relative min. Thanks for asking. Any other questions? Okay, so let's just take a second here. Let's review kind of, oh, I'm sorry, Josiah, go ahead.
I was just gonna say, do we have to, like, would we have to name that function above, like, the R2 minus ST?
You totally can. I don't think you have to. So if you wanted to, you could say something like this. We've done this before, right?
Yeah.
So we could say A of t is the number of cars at the dealership. So if that were the case, then wouldn't we say that A prime equals R minus S? And then if you did it that way, then you could just, instead of this, say A prime, and then you could say, therefore, A of t is at a relative min, right? So that would, if you did that at the start, that would actually shorten things up a little bit on the back end. There's no requirement that you do that, but if you do actually do that, make sure you tell me what A of t stands for. Don't just make up A of t and not tell me what it is. You're totally allowed to make up A of t or C of t or whatever it is that suits you. Just tell me what it is. And if you do that, then we're good. And you could do that on an AP test too. Like if you decide, you know what, this would be easier if I just made up my own function C of t, then I'm going to use that. As long as you name it and tell them what it is, we're good. Good. Okay. Any other questions? Anything I can help you with? Okay, so I believe that this is kind of the final one of these here. Let's do this. We're gonna cover speed, velocity, and acceleration here in a second. But I want to just review with you what we've done with these relative extrema type questions. The first one we did, I would say this one is a pretty straightforward in the sense that I gave you f of x, so you had to find f prime, use the first derivative test, and go with it. I'd say example number 2 is similar to that. The twist, of course, is you had to find a critical number based on f prime not existing. A little bit of a twist there, but then use the first derivative test from there. Example number 3 is a little bit different, right? Because I didn't give you g, I gave you g prime, and I didn't give you a function for g prime. I gave you a graph of g prime, and then you had to use that graph to tell me about g. That was a little bit different. And then example number 4 was the table. And I could tell, like, when you first saw the table, there was a little stress. It was like, oh my gosh, that table is gigantic, and there's numbers everywhere, and what do I do? Once you broke things down, it seemed like you made some good progress. So that one, be aware that that's a distinct possibility if something could be asked. Example number 5 was a little application, and you guys all recognize the water tank concept. Okay, so that's all 5 of the questions we covered between yesterday and today. Before we move on, any other questions? I want to give you every chance you need to ask a question. If you look in your extra practice as you think about preparing for your quiz on Friday, if you look through the extra practice, you will find there is a question kind of like that. So if you're looking for a fresh practice question, there is a water tank-like question. See if you can find it. You can use that. I would say the extra practice is great study material. Should get you as ready as you can be given the time that you've got. So, okay, let's take a look here finally at velocity and speed. And I'm going to give you a little demo here in a few minutes. But for now, let's fill in a couple of blanks on notes. Velocity. Tell me what you know about velocity. Okay, so it's a vector and it's the derivative of position, sure. So I'm going to say velocity is a vector, and I'm going to maybe say it's like the rate of change of position. Of course, that means derivative, but rate of change of position.
It's like the position per units of time.
Say again?
It's like the position per units of time.
Yeah, change of position per some kind of time. Yep. So it's a vector, and it's the rate of change of position. There we go. we could fill out a little bit more there, but that's good enough for the moment. Tell me what you know about speed. Speed is not a vector, it is scalar. So vector has a direction, and for us in this class, the direction is either going to be left or right, or up or down. Okay, we're keeping it really, really simple with one-dimensional motion instead of two-dimensional motion. You can do two or three-dimensional motion. That's just basically Calc 2 or Calc 3. That's really all it is. We're sticking with one-dimensional motion in here. So for velocity being a vector, basically you're going to go left or right or up or down. So direction is basically positive or negative. That's it. Speed being scalar is always going to be positive. I want to point this out in your car for those of you that drive. The little thing in the, like right behind the steering wheel is not called a velociometer. It's called a speedometer. And of course you've noticed that there's no possibility of negative numbers on your speedometer. As far as I know, unless you have a velociometer, yeah, it only goes from 0 and up. There's no negative numbers, it's only 0 and positives. I don't know that I would recommend you guys do this. Because when you're backing up, you should be looking in your mirrors and paying attention to where you're at. But for most cars, and there's maybe some exception to this, and let's not make the exception the rule, but for most cars, if you put the car in reverse and you start going backwards, if you go enough for the car to actually register your speed, the speedometer goes. Like, if you're going backwards at like 10 or 15 miles an hour, which is a little iffy, so I'm telling you to not do that. But if you happen to do that and you looked at your speedometer, just do this in a wide open field, you'll see the speedometer go. Not that one. You don't want a place with light posts or anything like that. No, not good. So, hey guys, we got time to finish this up. Let's finish it up. So if speed is scalar, so it doesn't have a positive or negative sign, it's just always considered to be a positive quantity, we could say that the speed function is the blank blank of the velocity function.
Absolute value.
It's absolute value. There you go. So speed could be considered the absolute value of the velocity. So we're going to look at two concepts here that sometimes are hard to picture. So I'm going to give you a brief demo. It's very high tech and give you the run with it version here. So here we go.
Speed up and ran into the wall.
Here we go. So speed is increasing when velocity and acceleration have the same sign. Speed increases when velocity and acceleration have the same sign. Speed is decreasing when velocity and acceleration have opposite signs or different signs. So you can just take that away from it. Like, that's the big takeaway from this. I hope the demo helps you remember it, but that's the takeaway. So if you were looking for an example that would go along with this, let's take a look at example number 6. It says the position of a particle moving back and forth along some linear pattern is given by S of t, and you see S of t right there. The question then says, is the particle speeding up or slowing down when t equals 2? So when you see that phrase, speeding up or slowing down, that's really asking, is speed increasing or is speed decreasing, right? Yes? It's Alpha Tuesday. Yes.
It's Alpha Tuesday.
So,
Today we're discussing why do you think the Bible is the world's best-selling and most widely distributed book? Lunch is provided.
So guys, hey, I apologize for the distraction. So if we are going to compare velocity and acceleration, don't I need to have a velocity and an acceleration function? What do I have? I have a position function. So how am I supposed to get a velocity function or an acceleration function if that's all I got? Derivatives, yes. So I'm going to say v of t equals s prime of t, and that equals 6t squared. Let's try that again. Minus 48t plus 90. And a of t is equal to s double prime, and that would be 12t minus 48. you find your velocity function, you find your acceleration function, and now, of course, that's acceleration velocity, that's at any time. I don't really care about any time. I care about what's happening when t equals 2. So what I want to do now is take my t equals 2, and I need to plug that in, and then I can make my analysis or come to a conclusion. So v of 2 then would equal... What do you get? 18, yes. V of 2 equals 18. 18 is an important number. We want to be accurate, but what's the most important thing about 18? It's positive, yeah. Okay, then we look for A of 2. A little bit easier. That's negative 24. Most important thing about that number is that it's negative. So because A of 2 and V of 2 have opposite signs, the speed is decreasing. So we just write that out as a conclusion. A of 2 and V of 2 have opposite signs. Therefore, speed is decreasing. Okay, so there you have it. Guys, that is it for 3.3. Do I see you tomorrow?
Yes.
I do. Tomorrow is review. No, do I see you tomorrow really? Yeah, I do.
Yes.
Tomorrow is review. Come ready with questions. Have a great day.